For our next presentation, will call Vasilis Filippo, which is a researcher in the search. He has a PhD in the use utilization from the Aristotle University, and he expertises in the forestry, renewable energy, and sustainable development sector. So, Vasilis, if you're ready, the screen is yours.
Thank you. Thank you so much for the introduction. Thank you so much for inviting us to present here in this those series of great workshops. And congratulations to the organizers for organizing such great workshops, and of course the presenters. What a great presentation we had yesterday's and today. I really enjoy every presentation. So let me share my screen and start my presentation. I don't want to delay you all. I know that the time has passed. So I'm Vasilis Filippo. I'm from Greece, and today I represent Energy Community of Karditsa. Energy Community is a cooperative, an initiative of citizens try to take the power over their hands and exploit and valorize their own residuals, their own biomass residuals, in order to produce energy. Of course, we are in Greece, we are in the regional unit of Karditsa, and if someone look at the geophysical map of Karditsa, can understand that we have mountains, we have landfills, and we have beautiful places like the lakes and stuff like that. So the 50% is mountain areas, and the other 50% is rural areas of cultivations. We are an initiative that started in 2010. Nowadays, we have more than 400 members. We integrate all the 7 cooperative values, and we try to tackle the energy poverty, and we try to do this in the most democratic ways that we have through an energy community. That means that each member has one vote, and can express their votes. So we start with biomass, and why we start with biomass? By all, we should now have understand that biomass produced in a local level, and most of the times convert into an energy in the local level. And when you try to convert it into energy, you create job opportunities. You engage the local community, you engage the local farmers, the local forest cooperatives, the local enterprises. So if you do this through an energy community, that gives a democratic uh, a democratic thing to the whole issue. I told you that we are in a rural area with a lot of cultivation, and this is the potential biomass that someone can find in the prefecture of Karditsa. We have cotton, we have maize, we have amazing wine, and we have grape prunings. We have the mountain areas, so we're talking about the residual forest biomass. We have the the municipal network of city trees, and we have the facilities that process the wood and have their own residuals. Of course, we are not talking into change our cultivations or to cut the trees in the forest, but we interested in exploitation only the residual biomass that coming from the area. So we have agricultural residual biomass, forest residual biomass, wood industry residues, and residual municipal biomass. And you can see here those residual, and we want those to valorize in order to, let's say, protect the forest and have a more sustainable community. Energy community start in 2010, but in 2016 we tried to found the enterprise a biofuel plant that can process the residual biomass and can produce refined salt biofuels in the forms of pellet. So in 2016 we start the operations, and since 2017 we process the biomass and we convert it into a fuel. So you can see here in the picture that we have all the necessary machinery in order to proper process the biomass and standardizes into the form of pellet of this refined solid biofuel. This is some pictures from our facilities, and this is the supply chain. It's in Greek, but you can tell by when you see the picture, you can tell the various types of biomass that we want to exploit. We want to exploit all the biomass that are available here in the local area, to take them into the facilities and then distribute it to the local community. Of course, the sketch was before the foundation of the solid biofuel plant. And in the pictures, in the right and the left, you can see the real supply chains that we have managed to achieve those years that we operate. But I want to emphasize and say our collaboration that we have then with the municipality of Karditsa. Of course, we engage farmers. Of course, we engage forest cooperative and wood industries. But the most crucial part is to engage the community and the municipality. So what we try to do is to engage with the municipality and take all the city tree cuts, the city prunings. This is a big headache for the municipalities all over the world, because each year the city trees produce city trees prunings, and this is a great headache for the municipalities. They don't know what to do with them, so we take the initiative and we collaborate with them in order to find the best solution. The municipality bring to us the city prunings, we process the city prunings, and we produce solid biofuels, and we distribute it again to the municipality. This is how the circle close of the circular economy type. So what we had residual biomass coming from farmers, coming from wood process industries, and then another Horizon project came to us, like BioRural. We call it the BICUB project, and through BICUB we try to expand the supply chain, and not only the supply chains, but expand our activities. So we valorize a lot of type of biomass, but we valorize coffee as well. You can see here the picture of coffee beans, and how we try to engage the local community, the local citizens, and try to pass the message of the circular economy to the society, and how we mix the coffee with the residual wood in order to produce an alternative, a new biofuel that we distributed back to the community. So in collaboration with InCommon is a participant in BioRural project, and with their guidance, we went through the coffee houses, door to door, and we try to engage them. We try to convince them to give to us the residual coffee that produced after the preparation of the coffee that we drink, and we try to make a map of this. So we briefly understand that we have each year 600 tons wet coffee, and that means that coffee right now goes to landfills, and for each ton, for each ton, the municipality pays a gate fee. That means in 1 year the municipality can pay a huge amount of money in order to dispose the residual coffee just in the landfills, and we want to reverse this. We want to take the residual coffee and produce a fuel. So if we could valorize the whole production of residual coffee, we can save a huge amount of money from the municipalities. Just to explain you how we try to do this, we put some bins in the center of the small town called Karditsa, and we engage the coffee houses and the citizens, and they dispose to that bin their own coffee residuals, and we take these coffee residuals, we process, we mix it with wood, and we produce the coffee pellet. It's a new alternative pellet that arise through the Bico project, and we have managed to produce, to make a solid supply chain with the collaboration of the municipality of Karditsa, with the collaboration of the local cafeterias, with the collaboration of mountainous municipalities and forest cooperatives. All those biomass streams come to our facilities. We further process it, the biomass we produce. So what we did was to create a solid supply chain with the local municipalities, with the local cafeterias, and what we did was to process the residual biomass and produce a coffee pellet, the refined salt biofuels, but also play the role of an ESCO, and not only selling the pellets, but instead install biomass boilers and provide all the direct heat to municipal buildings and to households. We try to do this through various workshops, info days, and small festivals in the region of Karditsa. We engage the local schools. Actually, a school made a school program. They call it "Don't Throw Your Fuel," and they collect 1 ton of residual coffee in 1 month, and they ask us to convert it into a solid biofuels, into coffee pellet, and then give it to vulnerable households in the municipality of Karditsa. And this is exactly that we did. Some people try to cover the heat demands through the coffee pellet that the students collect, and the municipality provide, of course, the city prunings. And for this program, that school won the Bravo schools and took the award, and they have some word that they use in the school. So, but we don't stop there. We try to make another pilot case. So what we did, we went to this kindergarten, a small school in the region of Karditsa. We replaced the old fossil fuel boiler with a new clever one system of pellet, and we use the coffee pellets, the mixture of the city prunings and the coffee pellets, and we cover the heat demands of the school 2 years in a row. And what we've learned about this was the coffee pellet was not only greener, but it was cheaper if you compare it to the oil and gas, if you compare it with fossil fuels. So with this example, we try to showcase that if the communities can valorize their own residuals, they can replace the fossil fuels, and they can stand their own feeds, they can produce their own energy. And right now with the municipality of Karditsa, we want to expand this network, and we want to go to other municipal buildings, and of course save money, and not only save money, but to move forward to a sustainable future. Of course, we are a community, we're an energy community, and we want to exploit not only biomass, but the sun as well. We have a project, we call it the Free Solar Project, in cooperation with the Greenpeace in Greece. We install some photovoltaics in some households, and right now 4 or 5 households cover their electricity demands as well through photovoltaic systems, and they don't pay to the grid. And we have this is our facilities, and with the red lines you can see that we own land, and we want to and we made applications to the grid operator in order to install 1 megawatt of photovoltaics in order to virtual cover the electricity demands of our members. And of course, we are a community that what we want to do is to engage the local community and to engage the local citizens to pass the message of the circular economy. And we don't do this alone. We do this with corporations, in common with CERT, that help us a lot in order to find the right recipe of the fuels. So briefly, those are the main aspects of the energy community, and of course I'm at your disposal for any further questions you may have. And of course, once again, I'm very sorry for these things that happened to my system.
Okay, thank you, Vasilis, for your presentation. It was very interesting topic. And I think now we are in the end of our session. So in the period of questions and answer, I would ask for the speakers to be with us. And we already have two questions in our chat. I would ask for the audience if they have any further question to write it down as well. And I think the other questions are from earlier speakers, but I will make a quick question here for Vasilis because it was he was the last one that presented here, and just a curiosity as well to start some discussion. Vasilis, you said that within this project you bringing together and working near the community. And I would like to know if it's difficult to engage the community or easier. How did you manage to get them engaged?
It's a great question. It's a very difficult part to engage the local community. Of course, they have a lot of misconceptions about biomass and about the use of biomass in order to cover the thermal or the electricity demands. What we tried to do was through collaborations with the municipalities in the small cities like the one that I showcased you in Karditsa, the municipalities plays a crucial role. So with collaborations with municipalities and other actors, we try to engage the community and arise the misconception they may have about cooperative schemes and about the exploitation of our own residuals for the energy productions. But it was
Okay,
very difficult, yeah.
okay. And it was done mainly through the schools or also.
We start with the schools because we believe that we need to educate the citizens of the future. This is why we start with the schools, but we want to expand the network through other municipal buildings. Let's say it's athletics in swimming pools and stuff like that. Athletic centers and swimming pools and stuff like that in order to cover the heat demands. Yeah.
Okay. Thank you.
Vasilis, sorry, João, may I make a question to Vasilis?
Yes, of course. Go on.
Vasilis, can you give us an idea about what was the total investment on the pellet plant? And all these, the supply chain is made. So do you pay for the transportation of the residues, or are uh, the companies or the producers of the residues that make the transportation to the pellet plant?
Okay, thank you for the question. The whole facilities cost 500,000, and the half of this came from member fees, and the other half of this came from a leader program. So the whole facilities cost 500,000, and right now it depends of the raw materials. So if we take the raw material from forest cooperatives or from farmers or for wood process industries, we pay for the raw material. But regarding the municipality, they provide us for free because we provide a solution to the problem that they have with the city prunings.
Thank you.
Okay. Thank you for the question. And I will now go for the chat questions. So starting for the first one, I think it's a question for Dr. Jorge. So Bruno Garcia asked, what are the main commercially available mini and micro ORC systems, and what is the capex opex? I don't know if you want to say something, George.
I'm not the right person to answer that question. I would redirect it to Juliana Maskman from Simon that made yesterday a presentation, I believe, But I would say that this is an emergent technology. There is not much offer, and the solutions are very client specific. But more detail, I would redirect it to Juliana, for instance.
Okay, thank you. We had this presentation from Steven yesterday. So Bruno, if you want to know more about ORC systems in mini and micro scale, you can contact them. The next question, let me see here. It's from Francisco Patrocinio. Let me see for whom.
Yes, the question from Francisco is to Joan. And Francisco, if I may help you, Joan.
Yes, of course.
Francisco is asking Joan, if you may change the feedstock, and if changing the feedstock to your process, if you will have a significant associated downtime.
The question is for me, isn't it?
Yes.
Yes. And I suppose that this person means to changing the feedstock. Yes, we can process. You can process with this technology almost all kind of feedstocks. If the feedstock in terms of particle sizing is just feasible and is campaign wise. Of course, it takes time because the calibration of the whole plant is based on the feedstock properties. So yes, you can change a feedstock, but it's going to take time in order to recalibrate the whole plant and the whole system in order to, based on the moisture content of the feedstock, based on the desired end product properties. So every time, the feedstock has every feedstock has an own fingerprint. So we need to recalibrate the whole system based on that properties. So it is possible, but it takes time and effort to make it campaign wise. It's not that easy that you can change your feedstock every day or every week. You need to make your planning in order to work a month with kind of a certain kind of feedstock, and you can change it afterwards, campaign wise.
Okay. So you during your presentation, Juan, you mentioned that you were in the development phase, and during the development phase, the size of the plant increased. Is that right?
No, for torrefaction, we are ready a long time ago. We are working in a scaling up line from I think the smallest one must be. Is that the question? The output capacity that we are able to deliver? Yes.
How small can you be?
Sorry.
How small can you be?
Yeah, how small? From the engineering point of view, we don't have limits. The limits are more economically. To be economical feasible with this kind of technology, we have seen something smaller than 1.5 ton per hour output capacity. It can be done, technically speaking, but economically is the most of the time not feasible under that rate of output capacity. And the maximum capacity that we are offering for the same reasons technically is possible to scale up even bigger, but transportation, logistic of other kind of issues are related to bigger machines. So we are doing 10 ton per hour output capacity. And in that range, between 1.5 and 10, we can deliver everything that is necessary. And we are standardizing about 3 ton per hour, 6 ton per hour, 10 ton per hour, something like that.
Did you think, and do you think it's possible to have a transportable plant? Something that can...
About what, sorry?
A transportable plant. Will it be possible to have a plant that can be moved from place to place?
Yes, of course it does, because I didn't have the time to explain that in detail. The whole concept is also a skid-based design. And the skid bases are exactly thought for transportation logistic and also for assembling. So it's quite easier just to move the skids from one place or another. But once again, like with the feedstock, you cannot expect that it's going to be a matter of days or something. It takes time to do that, but it's possible to move the plant to the technology was thought originally to go not to bring the biomass to the technology, but the technology to the biomass. That is the principle of the construction and the design, engineering design. But of course, even in that case, we are flexible enough and we have still improving the flexibility of the technology, but of course takes effort, a lot of effort to do that in the reality. So it's going to be a matter of weeks, of maybe months, to bring the plant from one place to another. But it is quite possible to do it. Yes.
Thank you, Joan.
You're welcome.
So I also have a question to Mantus. Mantus, um, you mentioned your whole process is based on bacteria, is that right?
Yeah.
And I heard about that nowadays when we are raising animals, we are using lots of antibiotics, and these antibiotics will appear in the sludge. So, is your process affected by the presence of antibiotics in the sludge?
Uh, yeah, it could be. We try to from running down a different type. For example, you can take the sludge, extract it, and check for like microbiology test, like Kirby-Bauer method, to see if there is some antimicrobial activities. So we currently have some cooperations with hospitals that we can use bacteria strains that are resistant to antibiotics, to check if we have something of that inside the sludge that we're using, because it will affect, as you mentioned, the anaerobic digestion.
Okay. So, and another thing is you have two kinds of residues from your process, liquid and solid.
Yes.
What do you do with that?
Usually they are using it for farming activities, because it could enhance in plant growth and promotion, like biostimulants, or in agrofertilizers, or stuff like that, as far as I know.
Okay, thank you.
Welcome.
Okay, we don't have any more questions in the chat. I would like to ask for the speakers if they want to ask something for each other, because